In libGDX and more code-centric frameworks, it's actually very easy to build your own particle effect within a few minutes. In this video, I show you how to develop such effects with just a few lines of code. So why not using libGDX built-in particle APIs, which is quite powerful and versatile anyway? You can, and it's totally fine to use the provided API. In more cases, it's relatively simple and straightforward to open the particle editors, play with the parameters, then export and load the effect into your game. However, there are three reasons that make me want to create my own particle system instead of using the built-in API. Firstly, developing my own systems grant me absolute controls of the particle lifetime and other properties such as its movement, motion path, colors, blending modes, which is necessary to implement advanced effects if I want to. Secondly, it helps me streamline my workflow much better than using an external editor. I don't have to jump back and forth between different programs and can focus all my attention on tweaking the effect variables right inside the code editor. And finally, because I create my own system, it is entirely integrated with my game logics and syncs up perfectly with different rendering states. I also have cleaner abstractions for my code, because the entities have better knowledge of the particle that interact with them. So that's all for the reasons. Now let's try to create a simple particle effect in libGDX. To begin, let's generate a simple project using GDX libdoc. You can use any project, packages, and main class name that you like. Also, pick the classic template so we have some basic code to start with. Once you're done, import the project into your IDE to run and test it. Now, NeoVim is my main code editor and I'm running it inside a terminal. I'm going to make a small shell script to execute the gradle task for me. On particle, use a single texture image as its main shape. For our effect, let's make a simple circle to define the particle shape. You can use any shapes you like, but the colors will be neutral or in grayscale so we can easily change the effect color later. Also, I'm going to use a command line tool called ImageMagicK to generate the shape, but you can use any image software to create the shape for you. Once you have the texture image ready, pack it into Alice file using texture packing utility and load it into our code as a texture region. Now let's move on to create the particle class. The simplest particle class usually contains its position and direction properties. The position tells libGDX where to draw each particle on screen, and the direction tells libGDX how to calculate the next position for each frame. Here, I'm also making a set position method to conveniently set the x and y properties for me. Now, to determine the direction, we can pick a random angle and convert it to direction parameters dx dy using trigonometry. And because the particle direction doesn't change in its entire lifetime, we can put the code inside the constructor. By the way, an advanced technique to abstract an entity direction is to initialize a temporary vector to object and call set angle degree methods on the vector. To learn more about vectors, check out this article on my website, which introduces a lot of useful concepts for using vector in game programming. To actually smooth the particle, you also have to update its position at every frame using an update method. Here we are using a particle speed constant to define the moving speed of each particle. Then we can modify the current position xy using dx dy, delta, and the particle speed value. That's it for the particle class. Now let's remove some boilerplate, then increase the window size and try to test a single particle movement on the screen. We are going to initialize a test particle instance in the create method and place it at the screen center. We also use a particle size constant to define the size of the particle. Then, in the render method, we call update on the instance and draw it onto the screen. If everything was done correctly, you will see a single white particle at the screen center that is moving out with some random direction. You can also experiment with custom values for the particle speed and particle size. Because we have a single particle working already, it will be super easy to make multiple of them. But first, to prevent garbage collection, you need to use object pool to recycle the particle instances. Here, we initialize a pool object and an array to manage the particle life cycles. The array contains the active particles on the screen, while the pool stores the inactive particles in memory. If you forgot how object pooling works, here's a quick recap. On the left side, you have a pool object that manages a collection of particle instances. To use any particle, you can call an obtain method and put it into an array. When you are done with a particle, put it back to the pool using the free method. The process repeats infinitely, so there no memory allocation occurs during the effect. Now let's create several particles when a user touches the screen. To do it, we want to record a touch point location in the random methods. Then we define a particle count constant to specify the total number of particles we want to use. Finally, we run a for loop to obtain those particles from the object pool. Drawing multiple particles is very similar to drawing a single particle. You just need to call the update and draw method inside a loop that iterates over the particle list. If you run the code right now, you will see multiple particles spawning from the bottom left corner. That is because we haven't set their position correctly to match the touch point location yet. Let's fix it now. Okay, it's working. The final step is to check the particle position boundaries. So if a particle goes out of the screen, we put it back to the pool and make it ready to be recycled. And that's it. The effect is practically done. Now you can try different combinations of the particle size, peak and count values to develop all kinds of effects that you want. One final issue we haven't tackled yet is the effect colors. Let's try changing the color using sprite-based set color method. If you compare this to what I showed you in the demo, the color seems up. That is because we are using a complete white circle to define the particle shape. Let's make a radiant cycle instead. Again, open your image editor and make a radiant circle from black to white. Here I'm using magic key command again to generate the shape for me. Now let's replay the old circle and see if it's working. It looks kinda ugly because we haven't touched the blending mode yet. Now watch the magic when I turn on blending mode. And just beautiful. The code right here sets the current blending mode to be additive, which makes the particles overlap region brighter. To learn more about blending mode, check out this guide on my website where I explain everything in details. And we are done. In the rest of the video, I'm playing with different particle parameters and colors and show you different effects you can try with the code. As you can see, developing a custom particle effect in libGDX is relatively easy and straightforward, and you can do a lot with just under 100 lines of code. Of course, this is just the basics, because you can develop and extend the effect furthermore on top of this. I hope you enjoyed it, guys. See you in our next video.